Today we are going to be reviewing on dividing with remainders. In 3.1a we're going to be looking at remainder form, B fraction form, and C decimal forms. In this video I'm just going to be reviewing decimal form and fraction form. You will want to go ahead and get out the Day 3 1.3ab practice or turn to this in your student packet for Day 3. I'm going to go over some of the answers and maybe a couple of rows here, and then you can finish out the rest of the practice and self-check and correct. First, we're going to go through and give you examples of how to write your answers in remainder form. Sorry about that. Remainder form. So if you look at the first problem, 27 divided by 4. Well, we know that 4 doesn't go into 27 evenly, but it does go in at least 6 times. 6 times 4 is 24, and then you'll need to subtract that from the 27, and you'll get 3. Now 3 is called your remainder. There's different ways to write your remainder. In remainder form, you will simply write remainder 3. That's what we did in late elementary school when you're first learning division. So let's go ahead and practice that with the whole first row. I'll do each one. 9 goes into 61 at least 6 times. So 6 times 9 is 54. If you subtract that from 61, you get a remainder of 7. This is a good check to make sure that you have divided by the biggest number possible without going over. Your remainder, that 7, should never be bigger than your divisor, this number that's out here. Alright, so we simply write remainder 7. The next one, 42 divided by 1, this does actually come out even. It's just 42. Because 42 times 1 has a remainder of 0. You could write remainder 0 like that if you really want to in remainder form, but you do not have to. The next one, 9 goes into 37, 4 times. The closest number I can get to is 36. 4 times 9 is 36 minus 37 minus 36 is 1. So you would have a remainder of 1. And the last example I'm going to do for you, 71 divided by 4. Well, 4 goes into 7 just one time. 1 times 4 is 4. I don't go to the whole 71 because it does go into the first digit. 7 take away 4 is 3. And then you bring down the next digit. It's 31. Now, how many times does 4 go into 31? It goes in 7 times. You'll get 28. 31 minus 28 then is 3. So you'd write remainder 3. So that's how you would do these in remainder form. The next part of the direction says to also write it in fraction form. I'm going to do these in purple. The answer, the whole number part, like in the first example, 6, still is the whole number 6. The only thing that changes is how you would write your remainder. In fraction form, whatever your remainder is, you will write on the top of your fraction or in the numerator. Whatever number you divided by, in this case 4, becomes the denominator. So the same answer, 6 remainder 3, can be written as 6 3/4. Let's try the next one. 6 and 7 over 9. The next one, 42 0 over 1, or just 0. When you have a remainder of 0, you will not have a fraction. You'll just have the whole number, the 42. The next one, 4 and 1 over 9, or 1/9. In the last example, 17 and 3/4. So on the rest of this practice, you want to solve all of these, write your final answer both in remainder form and in fraction form. When writing answers in fraction form, it's also important to remember that the fraction that you write can sometimes needs to be reduced. So if you turn the page, there is a whole practice on just reducing fractions. When you're reducing a fraction, you're trying to think of the biggest number that divides evenly into both the numerator and the denominator. So the first one is an example, 8 over 16 reduces to 1/2. What number did they divide by? What they did is they divided both the top and the bottom by the number 8. 8 divided by 8 equals 1, and 16 divided by 8 equals 2. That's the biggest number that divides evenly into both. If you don't pick the greatest common factor, is what this number is called, the biggest number that divides evenly to the top and the bottom, I'll give you an example of what that looks like, and you might be tempted to do this. You see 8 and 16, and maybe you're right off the top of your head, you know that both of these numbers can be divided by 2. Well, if you divide both the top and the bottom by 2, 8 divided by 2 is 4, and 16 divided by 2 is 8. The problem is that fraction is not fully reduced. It can still be divided again by a number that would divide it evenly. We can divide both of these by 2. So 4 divided by 2 is 2. 8 divided by 2 is 4. And we're still not done yet. 2 and 4 can both be divided by 2 once again. Do you see the problem this creates? You'd have to keep on reducing and reducing and reducing. So what is key here is that you always divide by the greatest common factor. Write this down here. You always want to divide by the greatest common factor, which we normally just abbreviate GCF. Sorry, I think it's probably pretty small on your screen. Hold over a sticky note so that you can see this. So the definition, greatest common factor, or GCF, is the largest number that can divide both the numerator and the denominator of a fraction evenly. One way you could do this, and I'm going to use the example, is write all the factors of both the numerator and your denominator. For example, the factors of 8 are 1 and 8, 2 and 4, and there are no other factors. The way I know this is because there's no numbers between 2 and 4 that can divide the number 8 evenly. That's how I know I'm done. Oops. Let's try 16. You always start with 1 and the number that you're trying to find your factors of. 1 and 16, and then I'm going to count out from 1. The next number after 1 is 2. So 16 divided by 2 is 4. I'm sorry. How about 8? Then I check to see if 3 works. Well, 3 doesn't divide 16 evenly, so I'm not going to use it. How about 4? 4 goes into 16 4 times. And notice that there are no numbers between 4 and 4. It's the same number. So that's how I know I'm done. Those are all the factors of 8 and all the factors of 16. When we're trying to find the greatest common factor, you're trying to find the largest number in both sets. Sure, both sets have a 2 in them, and both sets have a 4 in them, but both sets also have an 8. So 2, 4, and 8 are all called common factors, but the greatest common factor is the 8. And that would be the number that I would divide the top and the bottom fraction by to reduce it. Incidentally, when I reduce it, take a look at what's right beside those 8s. Right next to the 8, you see how I have a 1? And right next to the 8 under the 16, I have a 2. And look what the fraction reduced to, 1 over 2. Is that pretty cool? Let's try the next example, or problem number 1. Alright, we're trying to reduce the fraction 21 over 30. So I'm going to write 21 and 30. You might want to do these either on a scrap sheet of paper or on your notes pages for each one of these. Sometimes they'll repeat very frequently, so you don't want to have to write these all the factor pairs all the time over and over again. It's nice to have them on a sheet of paper that you can refer back to so you're not redoing some things. So the factors of 21, just like I did before, I always start with 1. 1 is always a factor of a number. 1 and 21. So then I count up. After 1 is 2. 2 does not go into 21, and I know that because 21 is not an even number. So then I check 3. I know that 3 can go into 21. 3 times 7 is 21. I check 4. 4 does not go in it. 5. 5 doesn't go in it. 6. Nope. And the next number after 6 is 7. So that's how I know I'm done. Check with 30. 1 and 30. 2 and 15. 3 and 10. 4 doesn't go into 30, but 5 does. 5 and 6. And the next number after 5 is 6. So I'm done. Those are all the factors of 30. Now, what is the greatest common factor? The largest number that's in both sets. 3 and 3. To reduce the fraction, look at the number that's right beside your greatest common factor, a 7 and a 10. So guess what 21 over 30 reduces to? 7 over 10. So problem number 1 is 7/10. I'll do another one with you. Problem 2 is 12 over 16. So what are the factors of 12 and what are the factors of 16? Factors of 12 are 1 and 12, 2 and 6, 3 and 4, and there's no numbers between 3 and 4, so I'm done. Factors of 16 are 1 and 16, 2 and 8, 3 doesn't go into 16, 4 does. 4 times 4 is 16. And because there's no numbers between 4 and 4, I'm done. Find your greatest common factor. Looks like it's 4. By the way, on that 16, it wouldn't matter which 4 I circled, because there's going to be a 4 right beside it. And if I put a square around the number that's right beside it, that tells me what the fraction reduces to. I have a 12 on top, so I put the 3 on top. And the 16's on bottom, so I put the 4 on bottom. 12 over 16 reduces to 3 over 4, or 3/4. So that's problem number 2. Sorry, I'm covering it up with my sticky note there. So once you've completed this whole page, open up your check page, or correct and check all your answers, and then go back to your previous page and see if any of the fractions on the previous page need to be reduced. I will have that on the correct and check too, by the way, or self-check and correct. If any of the fractions reduce, I'll write equal sign right next to them and reduce the fractional part of the remainders.